Okay, this is a little tutorial on how to do phase change problems. So first of all, you're going to have to keep in mind that even though we talked about calories, now we're going to be using joules. It's just a different form of calories. 4.18 joules is 1 calorie. For the heat of fusion, for melting or freezing, we'll use 334. That's up here. Anytime you have vaporization, like going to a gas or a gas back down to a liquid, that's going to be this right here. There's no change in temperature, okay, because it's a phase change. If we're just heating or cooling ice, this is the heat capacity or specific heat. It's the same thing for ice, solid ice. Okay. And then if we're heating or cooling water, it's 4.18 joules to change 1 gram, 1 degree Celsius. So specific heat and heat capacity mean the same thing. So for each of the problems, sketch a warming or cooling curve to help you decide which equations to use to solve the problem. Keep a reasonable number of sig figs in your answer. So first question is, how much energy must be absorbed by a 150 gram sample of ice at 0 degrees to melt and then to warm? So that's a phase change, and then you take that and you raise the temperature. So that means we're going to start, and I apologize if my pen is not great. So here's 0 degrees Celsius. So they're saying we've got ice, we want to melt the ice. It goes from a solid to a liquid. Then the liquid at 0 degrees then is heated to 25 degrees Celsius. Okay, so there's really two problems in one here. The first problem, okay, is going to be this one right here. To change to melt the ice, just like we did in class, we'll use Q, which is the heat to melt the ice, is the heat capacity or the specific heat of ice. Sorry, I apologize. The heat of fusion of ice, which is 334 joules. 334 joules for every 1 gram times the 150 grams. And I'm sorry if this is, my pen is not the best here, but I think you get the idea. 150 grams. Okay. Now, but then we have to add energy. And the second part here is we want to add more energy to take now the liquid right here and heat it from 0 degrees as a liquid to 25 degrees as a liquid, about to room temperature. And for that, we're going to need the specific heat or heat capacity of liquid water, which is 4.18. That's what we'll use. So it's going to be Q, there's Q, equals MCAT. M is the mass, that's that 150 grams, times specific heat, which in this case, or the heat capacity, which is 4.18 joules per gram degree Celsius, times the change in temperature, which is 25 degrees Celsius. So you really have, and sorry that this is so messy. Can't really do much about it. There you go. And then what we're going to do then is we'll then add these two Q's together, and that's the total amount. Okay. Now for the second one, we'll sort of follow the same type process. It's going to be a little bit different. Let's see what we have to use here. So again, here's this. Let's see what we're doing here. So what this has us do, it says you've got kilojoules, all this energy we're going to add to 150 grams of ice at 0 degrees. What's the final temperature of the water? So what really they're telling us here is some of this joules of energy, this kilojoules. Now, and first of all, just kind of to make sure here, this is the same thing as 65,000 joules. Okay, so with that in mind, some of that heat then they're implying is going to get it to go from a solid to a liquid. How do we figure out that energy? Well, to figure it out, Q is the mass, which is the 150 grams, okay, times the heat of fusion. And the heat of fusion is right up here. Same thing that we found, except we did it in joules, times 334 joules per gram. So I'm going to solve this just real quick, and I happen to have a calculator handy here. If I can get it to work, 150 times 334. This is like 50,000. So we've got 50,100 joules. Well, we have a total. This is just to melt the ice, right? That's just to get us to right here. That's what that Q is. We have 65,000 total that we can use. So what you want to do is subtract. I'm going to have units there. Subtract from this 65,000, this 50,100. And if I do that, I get that now I've got, if I do my math right, like 14,900 joules. So that's going to take this water that's a liquid and it's going to heat it up. Okay. How much? Let's find out. Okay. Q equals MCAT. 150 is grams to the mass. Specific heat or heat capacity for liquid water is 4.18 joules per gram degree Celsius. And I ran out of room times change in temperature. Now we're starting at 0, right? So really what you find for the change in temperature, it's 0. It's like the final minus 0. So it's really just the final. So if you solve for this, you can find that whatever heat's left over, how much is it going to heat it? We can solve for that, and we'll find what the final temperature of the water is. So really, it's just a game. All of these are going to use one of two equations. Either Q is the heat of fusion or the heat of vaporization. I'll put F, H, F, or V times the mass. Again, this is not the best pen in the world. Or it's going to do, if there's no phase change, we're just heating or cooling a substance with no phase change, it's Q equals MCAT, the mass times the heat capacity or specific heat times the change in temperature. Okay, that's what we're trying to shoot for. There you go. Have a great day and good luck with this.